Hey everybody, my name is Brandon Dennis. I'm the lead instructor and CEO of Red Team Nation. I want to welcome you guys all to the Hacking the Windows API with Python. So this particular course is going to go over in depth on how to actually use the Windows API, not just from a Python standpoint, but how to use it in general, which will give you a good idea of kind of what Windows is doing under the hood, as well as how to abuse some of this in Python. So you're going to be learning how to build your own portfolio for your professional use cases. You're going to be building security tools, everything from killing processes, wrecking tokens, and building out a impersonation toolkit. So you're going to get a good sense of familiarity with how all this stuff works and how to abuse the Windows with Python's API. Hey everybody, in this video we're going to be talking about how to build a professional portfolio for you as an individual and a professional. Now, the reason this is important is because a lot of job prospects and employers will look for some sort of portfolio from you. Now, this is more common in the software development field. However, in the security field, it's just as important, especially when you're trying to, it looks like you're giving back to the security community if you're producing tools, helping with open source projects, and GitHub is a very nice place for that. And it's a good place to host your own repository and your own projects, and that's what we're going to look at now. So the first thing we're going to do is we're going to pick a name. Now, this username can be whatever handle you're known as in the security community, or maybe it's a handle that you already like. However, try to keep it as professional as possible, right? So then next we're going to set up an email, and then we're going to set up a password, right? That's too short. Perfect. So once we've gone ahead and we've corrected a username, which it'll tell you if it's available or not, same thing with the email address, we set up our password and we go ahead and hit sign up for GitHub. So first step after this is going to be to validate the account. So we just have to do a quick puzzle of bouncing puppies and we should be okay. Perfect. So for free, that's all we really need. If you want to pay $7 a month, that's fine. But for an individual standard user, especially for something we're going to be doing throughout the course, which you're going to be uploading your own projects that you do throughout the course into this repository to be able to build out your portfolio. So we're going to go ahead and use free. And for personalization, we can just go ahead and skip the step. We don't actually need it. If you feel like answering these questions, go ahead. It does tailor the experience just a little bit for you guys. Perfect. So I'm going to go ahead and validate the account. Perfect. Now that we've gone ahead and validated the email address, we're going to go to the top right and we're going to click repositories. Now, this is where you're going to be building out your repos. So each repo can be a single file, can be an entire project. So in our case, we're going to be using single files, but treat them as projects. So to create a repository, which we're going to do, almost every single one of these videos throughout the rest of the course is going to be designed to have some sort of call to action to it. So whether that's building a Python script or doing something physically, there's going to be something. So any code that you build should go into this repository or a repository of its own, so that way you can start building out your portfolio. So to do that, we're going to go ahead and hit new, and we're going to leave owner the same since that should be your only option, and then we're going to do first-project, right? So that's just the name, and that's going to be the name you give it, and that's going to be the name people are able to search on, right? So on description, we'll just do my first project. And we'll leave this as public. Now you can do private ones where it's just for you, but that's not what we're trying to do here. We're trying to keep it public. So we'll do initialize a README, which is more of like a base description. And for git ignore, we're not going to go over this for now. Just make sure it's Python, because that's what we're going to be using. We're not going to be using the command line per se, which is going to be where this is most prevalent. However, feel free to give it a quick Google search. Git ignore, just when you're using the command line git, it just ignores specific files like compiled Python files. So we'll go ahead and click create repository. Perfect. Now that that's done, you can see there's a few options here. We can upload files, which if you click this, you can just drag and drop specific files, which is probably what you're going to be doing, and then add some comments to it, and then commit directly to Matcher and hit change commit, right? Or we can do create a file. Now create a file, you can do, test.txt, whatever you want, right? However, if you want a folder, you could just type it whatever and use a slash. And that will go ahead and put you your folder, and then you can do test.txt if you want, or .python. So that's how you add things to your project or your repo, and how to create a GitHub account. So what I want you guys to do is take a second and go ahead and go to github.com. If you can't find it, there will be a link in the resource side of the site. and go ahead and create your own GitHub account. What I want you to do is if you have personal projects that you're okay with sharing, go ahead and already upload them. Start building that portfolio out sooner than later. And as soon as you have a few bits of code on there, you can start putting it on your resume to help buff things up a little bit. So go ahead, build out your portfolio, and let's see how it looks. Hey everybody, in this video we're going to be going over how to set up our environment. That's going to be our base point for the rest of the course. So what we're going to do is we're going to assume that you already have a VirtualBox with Windows installed, right? If not, I will leave a link in the resource section to VirtualBox, the Windows ISO for the download for the installer, as well as a tutorial for how to use VirtualBox to install Windows. So go ahead and do that first if you haven't already, and then once you get to that point, start it up and you'll be right here. So the next thing is we're going to need to install a few tools and a few products into Windows for this particular course. We're going to be issuing Python 3 for the environment because we're using Python 3 for the code. Then we're going to be using Notepad++ just for a simple editor that's quite easy to use. Then we're going to be using a few things from sysinternals from Microsoft. We're using PsExec and Process Explorer. Then on top of that, we're using something called Dependency Walker that will then allow us to look at PE file structures and exe file structures. All right, so the first thing we're going to go ahead and do is install Python 3. Perfect, so we're going to go Python download. Go ahead and grab the first one. Again, all the links for the exact places to download this are going to be in the resource section next to the video. So in this case, we're going to download 3.7.3. And this should auto understand your operating system. We're going to go ahead and add Python 3.7 to the path, install for all users, and go ahead and install now. Go ahead and click yes to the UAC prompt there. Perfect, so now that that's done, we're going to go ahead and hit close. And we're going to go ahead and test out to make sure that Python is installed correctly. So at the bottom left, you'll see the Windows logo. Go ahead and right click on that and hit run. And then type CMD and hit enter. So that's going to bring us up our command prompt. Now at the bottom where the logo is for the command prompt, just right click that and say pin to taskbar. So that way it stays there so we don't have to search for it later. So we're just going to do Python -- version. And perfect, so we got Python working correctly. Awesome. Next thing we're going to do is do Notepad++. Perfect, go ahead and go to download. And we'll download the latest one. And we will go ahead and run that as well. And again, yes to the UAC prompt. And we're going to go ahead and hit OK. And next. I agree. Next. Next. And make sure we click Create Desktop Icon and install. And that's it. We'll go ahead and let it run automatically the first time. Perfect. So again, we'll go ahead and right click the icon here and do pin to taskbar so we automatically have a nice way to grab it. Next thing is Process Explorer. So Process Explorer. Go ahead and click Docs. Again, every link that I'm going to specifically you will find in the resource section next to the video. So go ahead and click Download Process Explorer. Let's go ahead and open this up. Perfect. So we'll just grab the two Process Explorers and go ahead and drag them onto the desktop. Next step here is we're going to do PsExec. I'll explain what each of these tools do in their respective videos, but just go ahead and download them ahead of time so we have them ready to go. Okay, go ahead and click Download PS Tools, and we'll go ahead and open it. So we just need the standard PsExec right at the top. We'll go ahead and drop that over. Done. Now, the last thing we need is Dependency Walker. Again, we'll use this for PE PE identification and looking at a few things such as undocumented system calls. So this will be a good tool to get familiar with, especially if you're doing any type of malware reversing or reverse engineering in general. So we're going to go ahead and scroll down to the bottom. Oh, not quite to the bottom. And you're going to grab this one right here. I know it says for Windows 7, 8, etc. This one does work. Go ahead and download that. And go ahead and open it. And we will just need these two depends and depend.dll. Perfect. Okay, that should be it. You should have your environment pretty much set up now. And again, we'll have links for all of these things on the far right side of the video in the resources section. So go ahead, get all these downloaded and get it set up, and then make sure Python is running correctly. If you have any problems, hit me up with a message and we'll go ahead and sort it out. Hey everybody, in this video we're going to be going over Windows internals as it portrays to the API calls. So this is not going to be a full in-depth guide on how Windows internals works. There's thousands of guides. I'll link to a few next to the video so you can get a little bit more research on how the subsystems work. However, we're going to go over some topics that we need to cover before you can start getting into the Windows API. So the first thing we need to look at is what is a process. Now a process can be your web browser, can be Notepad, can be any other application that you have running. So a process is a currently executing program. We're going to go ahead and go over what threads are in the next slide, but just keep in mind a process has one. Now each process as well as each thread has its own virtual memory space. So the space for this particular process is self-contained to itself. So that means other processes can't just come in and reach in and see what it's doing at any point in time without some sort of elevated privileges. So a thread. Now threads run inside of processes. Now a process is just a shell while the threads actually do the legwork, right? So an operating system, in this case Windows, will allocate processing time to the CPU to each thread. Now this can be done through thread pooling or a few other things. I'll link to a few bits of information about that as well. Now each thread executes code based on what's in the PE or the exe file that was ran. Now this can change slightly if you're using a binary or a PE or exe that happens to be running some custom code on the fly on a different thread, then it will go ahead and run whatever it is. So just keep in mind that threads run code. A thread can create more threads that run different code. So threads can actually create more threads that spawn additional threads. This is why you have one core thread for an application or a process. And then there might be 5 or 10 other processes or threads that get started because there might be for example, one thread might be handling each client that's connecting on a server, if that gives a good example. Now, when it comes to processes and threads, every process has something called an access token or a security context, or normally just called a token. These are used to deal with privileges and access rights for a process or a thread. So every process that's running, whether that's Explorer.exe for the desktop, whether that's Notepad or any of the system level processes, everything has a token. And that is very important to understand because we're going to be playing around with tokens directly in this course. So some of the stuff the token contains are the privileges, like I said, such as SEDebug, if you've ever been familiar with that, the user groups, the type of token, whether it's a primary or a impersonation token, which we'll go over later, as well as the default access control lists. So we're not going to dip too much into the internals of a token. We'll hit that in future videos, but I will leave a little bit of more research and some links for you to take it a little step further if you want to go there right now. So how are tokens used? Tokens are passed and used in almost every Windows API call in some way, shape, or form. Now, this is normally passed by something called a reference. So when we go further into this course, you'll see pass by ref or pass by reference, which basically means instead of sending it raw data. So you should be familiar with Python if you've gotten to this point in the course. So think of your variable. If you just pass the variable itself, you're passing the raw data, such as a is equal to 1. However, what we're doing when we pass by reference is, if you guys are familiar with C, it's also known as a pointer. So you're passing the physical memory location to the function that you're calling, right? So when you're passing tokens in an API call, normally you're passing the memory location of where that token is actually set. Now, this can be used to call, files, memory locations, but it's all based on the process's initial token. So, and what's important about these are you cannot add new privileges to a token. the token has to be rebuilt from scratch, which means there's a new process that has to occur. And a token, like the very first, let's say you're running Notepad as an example here, and that process's token is very minimal. So because of that, every token that it creates past that point for additional threads can only be at max what the current token was. That's why when you're running things in the system, your initial token has all the privileges. So you can create tokens that have base restrictions on them as you want. So it's important to keep in mind that you can't add permissions to a token. You can take them away, and you can enable and disable ones that are already present, but you cannot add to it, which is an important concept that we're going to go over a little bit later when we start crushing processes and removing privileges altogether. So what is a handle? This is another bit of terminology that you're going to have to get your head wrapped around. So in Windows case, it's an object that points to a memory location. So in this case, it is a pointer. So similar to how when we talked about tokens here, where I said you're passing by reference, essentially the bit of data in memory that holds that reference can be considered a handle. Now that, like I said, this normally points to a specific process, the process's token, or raw data. And this is passed just like it is as a token. Like I said, it tends to be direct memory locations. However, in some cases, it points to an abstract object even further that then points to the memory location. But in those particular cases, we'll be able to tell by looking at the documentation. So we'll get to that in a little bit. So the last part of a Windows API is the Windows structures. And this is where people tend to start freaking out a little bit. It's not as bad as it looks. There are a lot of structures inside of Windows, and sometimes when you're calling 5, 6, 10 API calls for an application, you might have 8, 9 different structures that you have to pass and create. This can create a lot of code for something very simple. But in this particular case, I don't want you to worry too much about it. We're going to go over it in great detail when we start building this out and actually using them ourselves. Now, Windows structures are similar to handles in terms they're abstract structures that in memory that hold data in a specific format or a specific way. Like I said, this is normally passed to an API call, or it can be returned from an API call. So in this example, we have process information. So this is normally a structure that gets returned from a Windows API call, right? So it's going to return a handle to the current process that was created, the first thread that was created, the process ID and the thread ID. So you get a good base of the process's initial information once you start it. So this is a good example of how this works. Now we're going to hit all of this in much more detail. So as we go through the rest of the course, you're going to hit each one of these, but I will leave quite a few links for you guys to do additional research if you want to, and then we'll feel free to hit up the next video. Hey everybody, in this video we're going to be going over a little bit more details on the Windows API call itself and kind of how it plays into everything. So what is an API in general? An API is an application programming interface. Now this can be from everything from a web application to internal operating systems. So these are normally high-level interfaces for developers to speak to the operating system or to some background service if you're looking at it from a web API, right? So all processes will use the Windows API in some way, shape, or form at some point during code execution. Any process that wants to do anything such as opening up a web browser or opening up a GUI or writing a file, all of that is done through the Windows API. Now, parts of the Windows kernel also use their own internal API, which we'll go over in a second, as well as each API call is located in a specific DLL. Again, there will be a whole slide on that. When you look at API calls, there is user space. So when you initially get on a machine, let's say you've logged into your Windows machine, you are in user space. When you launch a process, such as double-clicking Chrome or Internet Explorer or Firefox or Notepad, whatever you want to use to open up a process, you are opening up a process in user space. Now, when that process needs to do something, let's say Notepad needs to open a file, it needs to issue a high-level API call, which now this high-level API call right here is going to be what we are focusing on in this course, which then it calls to the kernel subsystem or the Windows subsystems, which in then turn call their own low-level APIs, which we're not going to be going over, but just keep in mind that it does exist. Now, APIs can be used to create anything from malware to perform privilege escalation, new exploits, or even perform reconnaissance. Now, in this particular course, we are not focusing on the malware at any point. I'll have a whole nother course dedicated to how to create that. But we're going to focus a little bit on the reconnaissance and a little bit of working with privilege escalation. So what does an API call look like for Windows? So it's similar to any other function that you would sort of find in most languages. So you can see here, the first section here is a return. So in this case, it returns a handle. And the first call, or the name of the call, is find window A. We'll go over why the A is there in the first place. So what this does is this finds a window and returns a handle or a memory-based object to the process based on a window name. Now you can do it for a class, which is a string, or the window name. Now we'll hit this up in the documentation more specifically. But these are considered parameters. Again, no different than a function in Python. Now, when we go through the documentation, or when you do this on your own as well, or even future in the course, you're going to want to keep track of what each parameter does based on the documentation, because in some cases it needs a reference to the data, or in some cases it takes the raw data itself. And that's very important because working with Windows API calls can be a little tricky and they don't always tell you what's wrong. So for API extensions, such as the one we just saw over here for find window A, you'll see stuff with W, A, and even EX, or multiple versions of EX, such as EX, 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 at the end of some API calls. Now, when there's a W at the end, it will use ANSI, which is not to be confused with ASCII characters, but it'll use ANSI strings as its input and output for some of its parameters. When you have an A at the end, similar to this find window, you'll be using Unicode for its input and output. Now, this is important to understand the difference between the two, and that'll change how you pass the information, so just keep that in mind. Now with EX, that's normally a new version of a previously built function. Now for backwards compatibility, you'll still have the original, and then if there's a new version, you'll have EX, and if there's a new version of the new version, you'll have EX, EX, and vice versa. It'll just continue on in that process, and I've seen a few with EX, 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 EX. So keep in mind, it's just a newer version, and sometimes you might want to use the older version over the newer version, and the documentation will normally tell you what the differences are between them. Common window DLLs. Now DLL is a dynamically linked library. Now for those of you familiar with Python, this can be thought of as just loading in a module. Now all of these Windows API calls are stored inside of the DLLs. Now they're separated based on the DLL. So for the networking ones, the networking API calls, you'll be in the networking DLL. And we'll go over that in just a second. So for kernel 32.dll, and keep in mind this is not a whole complete list. I'll leave a link to a few more next to the video, but this is just a quick list to kind of get you more familiar with this, right? So kernel 32 is used for interacting with processes such as the find windows, the file system, starting threads, starting processes, all that's handled by kernel 32. Then we have ADV API 32. Now this handles Windows registry, Windows services, user accounts, and shutting down the system. User 32 is another common one. This is for the graphical user interface or the GUI, messing with fonts, the windows themselves, the keyboards, the mouse, all that type of fun stuff you'll be doing with user 32. So when we pop up message boxes, that would be under user 32. Net API 32 is just the access and networking components, and this is broken down a little bit further. We're not going to go to in this particular video, but you'll see it broken down further in the course, such as the DNS would be a different DLL. Now shell 32 is to access the Windows shell or the command line. Sometimes you'll use this, sometimes you won't. It just entirely depends on what you're really trying to get after. But this is not a full list, but you'll find that when we start looking at specific Windows API calls in the documentation, it'll tell you what DLL it's in, so you can automatically reference that in your code directly. When it comes to API calls, there are documented and undocumented calls. Now, the documented calls are the ones like, for example, find window A, which is commonly found in the Windows documentations online, but there's others that Windows uses that are not presented. Now, we're not going to go over in depth on how to take a undocumented API call and go through all the reversing to be able to find out how to get it to work. But there are some places where people have used and done that step for us, and we'll look at how to use undocumented calls that are already investigated, but maybe not in the documentation, and we'll do a separate course on how to actually reverse these ourselves. So now it's time to actually take a look, and we'll take a look at this live. This is the Windows docs. So when you're working with Windows API calls or Windows in general, you're going to find yourself on this site a lot. And I'm going to leave a link to this as well. Now, when we look at this, we're looking at the find window A as an example. So we get here, it says retrieves a handle to the top level window whose class name and or window name matches specified strings. So if we take a look here, we have you can see here it returns a handle, which is what we expect. We're doing find window, and it returns a string. So we'll go over which type of string this is and how to identify that in future videos. Just bear with me as this is a string. So we can see this a class name or a class atom created by the previous calls to class register class EX. So you can see here, if class name is null, it finds any window whose title matches the window LP window name parameter. So if I were to call this particularly, I would put null here, and then I would give it the Windows title, such as Notepad++, Task Manager, whatever we want to do. So the return type here is specific as well. So if the function succeeds, it returns a handle to the window that has the specified class name or the window name. If it fails, now keep in mind the fail part is important. Not all Windows API calls fail the same way. Some will return null, some will return a not null if it succeeds. In this case, if it fails, it returns null. And we'll go over how to identify what error occurred in the future videos. So remarks is also a good part. If you're messing with adjusting token privileges, it's a good idea to read the remarks section. It kind of gives you a little bit more insight. But the last thing I want to show you guys on this particular page is the DLL. So if you're never sure and you find a DLL or a Windows API call that you need or want to use, and you don't know what DLL it is, you can always just come down here and find it. Now, if we want to search, again, we can do, duplicate token. We can go ahead and search it. So we can see here, duplicate token, self-impersonation, duplicate token EX. So if this is the one I wanted, I'll go ahead and click here. And you can see it takes us to a very similar looking page. Here's it takes in a handle, takes in a desired access, takes in a structure. So you can see here, if we needed to figure out what structure we wanted, we would scroll down here and we can see a pointer to the security attribute structure. So if we go ahead and open that up, we can see that this is the structure that needs to be passed, which is why when I said Windows API structures or calls use massive structures, you can find yourself going into a pretty big loop. So these are the documented API calls. So what if we wanted to see an undocumented one, right? So we're going to use Dependency Walker, which I will link to the download next to the video as well. So when we go ahead and use Dependency Walker, we're going to open up an application called ipconfig, which is something you guys would have used before if you're familiar with Windows. So we'll go to this PC, local PC, Windows, then we're going to go to System32. And then down here we'll do ipconfig.exe and we'll go ahead and open it. So we'll go ahead and ignore the error. So for now we'll just collapse this a little bit so we can get a little bit more space here. So these are the DLLs that we were talking about before that are being loaded in. So in this case, MSVCRT. So you can see these are some of the calls that are being used, but we'll look at DNS specifically. So with DNS here, we can see it uses the DNS flush cache resolver, DNS free. DNS get cache data table is not a documented syscall. And keep in mind, this is going to be one that we're going to use in later videos. So just keep an eye on that one. But that is an example of an undocumented syscall that's being used by a Windows application. So go ahead and download the Dependency Walker, open up ipconfig, and navigate through this and take a look and search for each one of these, including the DNS get cache data table syscall or API call. Go ahead and do that. Go through this, as many of these as you can, and find out what each one does, find out what structure it is, trying to get more familiar with looking up these calls and see how it goes. Hey everybody, now that the base information out of the way, we can get a little bit more hands-on. So if you haven't already, make sure you have a Windows VM set up, we have Python installed, and we have Notepad++ installed. That's all we're going to need for now. So once you've got all that set up, we're going to be looking at something called C-types. Now C-types is what we are going to be using to interface in Python with the Windows API. Now C-types can do a lot of things. It can touch into the Windows API as well as your own custom DLLs if you want to. We're not going to be going over the custom side of things in this particular course. That'll be in the malware course. But for now, we're going to be looking at the Windows DLLs such as kernel 32, user 32, etc. What I want to bring your attention to is this specific page. Now I'm going to have a link to this page as well next to the video. But what's important about this is a good frame of reference, because there's a lot of times if we look at this message box right here, for example, LPCWSTR, right? So we might not understand what that is, per se, and eventually you'll get more familiar with a little bit on the Windows APIs and what kind of they're looking for. But you can see right here LPCW-STR, and it is a wchar p. So in this case, it's a pointer to a char, which means we're going to be working with a string. So it's important to understand that. So we're going to be using this as a reference between a lot of things, and you'll get more familiar with these specific types and what you can and can't get away with either using a standard string in Python or a standard integer, or sometimes you might need to call these specific types directly in some cases, or even these. But we'll go over those specific instances at that point in time. Those will be in a future video. Now, if you're not familiar with Python, I'm going to recommend you take a pause for a second and use the link next to the video to look up a little bit more on Python. You'll need to know, at least the basics to kind of get through the course to have a better understanding of how this stuff works. So again, if you're not familiar with Python, go ahead and take a look at that now. So with that out of the way, we're going to go ahead and look at our first program, which we're going to be using. It's called Hello World, and we're going to be using the message box. So in this case, we're using message box W. We can see that it takes in a handle here, then it takes in a LP text, a caption, and a type. So if we take a look at our individual parameters, a handle to the owner of the message box we would create. If this parameter is null, the message box has no owner, which is fine. In our particular case, we'll leave this as null. We don't need to worry about it unless you wanted this to reside or be called under a specific process. Then you would put the handle to the process here. In our case, we don't necessarily need that. So the LPC string, which is the L text, now this is going to be the text to be displayed in the middle of the box. And then we have our caption, which is aka our title, right? So this can be null. The default title is error if you left it that way. And type for unit, which is a unsigned integer. Now this is what type of message box, right? So you have an OK cancel, then you have a retry cancel, yes or no, yes, no cancel, try again, abort retry. All these are individuals. Now, it's important to understand we don't need the L in this particular case. This is going to be the 9th character. We're looking for the first 8. And you're going to see this a lot when you're working with the Windows API, where you're going to have to pass in specific hex, right? So if we look here, we're looking for 1. So this is our standard, which is what we're going to be using. And feel free to test a few of these out. Just drop the L off the end. So in this case, we're looking for an OK and cancel. So now we've got an idea of what our parameters should look like. Let's see what it actually looks like in Python. So the first thing we're going to do is open up Notepad++. Perfect. We're going to go ahead and make the text a little bit bigger. Perfect. Now with the text a little bit bigger, we're going to go ahead and do File, Save As, and we're going to save this to our desktop. And we will just call this helloworld.py. Perfect. So now we've got our baseline. Now, just like any other module, we need to import it. So we're going to import ctypes. Now this is going to be our base level. Everything we're going to be using is going to be used off of this. We won't need any extra imports for the time being. We might use a few other base Python modules, but nothing else for the Windows API we'll need other than ctypes. Now, when you're interfacing with a DLL of any kind, whether it's the Windows API or not, we need to actually import that DLL and let it be available to the Python module. So if we look back here at message box, we need to know what type it is. What DLL is this in, right? So if we scroll down to the bottom, we can see it's user32.dll. Perfect. So that's important for us to know because we need to make a handle to the correct DLL. So the way we do this, and we'll do user handle is equal to. Now this is where some of the syntax comes in. We're going to do ctypes.win DLL. Now this will change depending on what you want to load. So in our case, we're using user32.dll. That's it. So now we've generated a handle for user32.dll, so we can use ctypes in turn as a proxy to reference whatever API calls we want that resides inside of user32.dll. So our win API call requires a few different parameters, as we could see here. So we have our handle, our main text, our caption, and our type. So what we're going to do is we're going to set these variables up. So hwind, which is our handle. So we're going to keep this as none. Now, in most cases, none will work in term for null. So don't worry too much about that. There will be some use cases where it's not applicable, but we'll go over those when we hit them and how to identify them. But for now, we don't need a hardware handle at all because we're not referencing it to a different parent process. So the next thing is our text. So LP text is equal to, so whatever we want it to say. So we'll do hello world. Awesome. And then LP caption, which is our title text. Let's do hello students. Awesome. Now the last one is utype. Now the way this works is we picked, remember it was 001, or I'm sorry, it was 7 zeros and a 1 right afterwards. So we can see right here. Now we can copy and paste this directly. That's entirely up to you. Or you could just type it out. So 0x12345671. That's it. That's going to be a OK and cancel box. So all we need to do to actually execute the call is run user handle dot whatever the API call is. But we're going to want to catch the response in some way, shape, or form. Now, not all API calls have a response, as we've talked about in previous videos. So if we come down here to response or return value, right? So there's going to be different return values that response is going to give based on what the person actually clicked on. So if we get a 1, we get an OK. If we get 2, they clicked cancel. So as you can see, there's a few different options, and you could adjust your code accordingly based on what the output was, right? So we want to catch the response. So if we do response is equal to user handle dot, and then whatever the actual API call is. So message box W, and capitalization is very important. And then we pass it inside the parameters that we're looking at. So this is in order based on the docs. So we do hwind, hwind. Then we pass over LP text. Then we pass over LP caption. LP caption. And then utype. Now, technically, if we just ran this, it would work. But what we're going to want to do is handle a little bit of error handling, right? So error handling is very important when writing any type of code, but especially when you're working with the Windows API. If something just doesn't work, you're not going to know what happened. So to sort this out, kernel 32, the DLL kernel 32 has an API call called getLastError. And all that does is that provides you the last error message that was present on the machine. So for example, if you wanted to, you could print out the last error here and then print it out right afterwards. So you should get a 0 if everything was working correctly, or if you get anything above 0, something went wrong. And I'll leave a link to the Microsoft Docs section of their website that allows you to quickly look up these codes, because that's going to make your life significantly easier. So when you're debugging things and you see things aren't working the way they are, or even after you test each syscall or API call, you're going to want to just do a quick double check and make sure there's nothing wrong from the message, because it might look like something worked, but if the last error actually produces some sort of result, it may not have actually worked fully, because again, there's multiple API calls that are called past this particular message box, for example. So for now, we're just going to go ahead and run this. So we'll go ahead and open up our command line, and in my case, we saved it to the desktop, so we'll do desktop. And then we're going to do Python hello world. So we can see here, hello students is our title, hello world is the text, and we can click OK or cancel, right? So if we come in here and change this to a 2, that should give us a different type of box. And we do. We get our abort, retry, and ignore. Perfect. So go ahead and play around with that. But in this particular case, we're going to do a 1. So we need to worry about error handling. Now to do that, we need a handle to kernel 32. So we're going to do khandle is equal to ctypes dot win DLL, and it is the same, kernel 32 dot DLL. That's it. So now we handle our error message. So we're going to do error is equal to khandle dot get last error. So that'll go ahead and get the error. And remember, anything above 0 means something went wrong. And we're going to want to let the user know that. So if the error does not equal 0, we want to go ahead and print that there was an error message. Error code. And then we'll go ahead and format this and produce the error code. In this case, we're going to do error. And we're going to go ahead and exit 1 to let the operating system know something failed. So now if something were to have failed, we would then get an error message. This is just a little bit of a precaution. So if we go ahead and run this, you can see everything looks fine, no problems. So what happens if we want to deal with the output, right? So what we're going to do is we're going to check that response. So if the response is equal to 1, then the user clicked OK. Yeah. User clicked OK. As you can remember, when we looked at the responses, user 1 means they clicked the OK button. So if we looked for 2, they had clicked the cancel button. So if we go ahead and look at this again, so if we do else if response is equal to 2, then we're going ahead and print user clicked cancel. That's it. So if we go ahead and run this, we click OK, user clicked OK, and if we click cancel, user clicked cancel, and if we clicked the X, the user still canceled. So the X is always still cancel. So this is a quick example of how to do hello world inside of a message box while calling the Windows API. Now it's important to get this structure down, understand where each section of this falls into place. Make sure to rebuild this yourself, and what I want you guys to do after, just like any other of the exercises in future videos, every time you build a complete application such as this, write your documentation, write what this is supposed to be. Add some notes in here, right? So add some comments in here, not used, and then what it is, right? So get familiar with writing your own documentation. For example, you know, handle to user32.dll. Just so anybody reading the code in the future has a better idea of what was going on, and it's just helpful for the next person to understand how things are done the way they were. So go ahead and document this up, and then I want you guys to upload this into the GitHub account that you guys already created. Now that we've gotten some of the basics out of the way with how to interact with the Windows API in Python, we're going to take this a little bit further. Now, everything in this course is going to build on top of each other, so keep that in mind. So we're going to get significantly more advanced as we go through. However, if you are ever running into any problems, just let me know in the Q&A section or send me a message, whatever you need to do, and we'll go ahead and sort it out. So what you normally use is when you open a process, it's called open process. Now this is the Windows API function. There's countless different functions that will, or API calls that will give you the access you're looking for or give you an access to a handle. And there's different ways to go about it. And depending on what your end goal is, will change how you open that handle. So in this particular case, we're going to use just a basic open process Windows API call to actually go ahead and just open a simple handle with full access rights, if possible, to another sub process, right? So if we look at this, open process returns a handle, which is what we'd expect. Now it takes in a D word, which is desired access, a Boolean, that is whether it's inheritable or not, and then a process ID, right? So if we take a look quickly down at our parameters here, to access the process object, the access rights is checked against a security descriptor, aka the token. The parameter could be one or more of the process access rights. So if we go ahead and look at the process access rights, we can see kind of a good idea of what we want to use, right? So if we want delete access, you know, read, control, synchronization, we want to be able to modify the default access control list, or we want to be a writable owner. These are some of the different variables in different options. Now these are called standard rights. And then there's a few more advanced down here, which is mostly what we're going to use is for process all access, which is what we're going to try to do initially. And there's a shortcut in Python so you don't have to copy basically all of these and dump them together into one large string to get basically this same access. There's a little bit of a shortcut, but if you want to add all of these together, which you'll see in the actual code, you can do that. But when we look at that parameter right here, desired access, we would be adding basically all of these together to get us process access rights. So the next step here is the inheritable handle. So if this value is true, the processes created by this process will inherit the handle. Otherwise, it does not. We'll keep this as false. We don't need to worry about that for now. And then the process ID. Now, it's important to understand here that if the process system is basically 0 or null, if that is the specified process we're looking at, and the function fails, the last error code is going to be this. So in case you see invalid parameter for whatever reason, and you're trying to touch the core system process, then you're going to get that particular issue. And otherwise, in some cases, it'll fail with access denied because our token in the Python code, so for example, when we generate our first, and go ahead and run the Python. So when we come in here, for example, when we do Python, hello world, right? So this command line has a token that was generated by explorer.exe, and explorer.exe has a specific token based on our access of our current user, which and then that is used to create this at least that access or less. And then when we call Python, we get whatever this access is or less. So for example, if we get access denied, it means the token privileges in this command line and the sub process for the Python call was not high enough for us to touch whatever process what we're actually looking at. Then we have our return value. So if the function fails, it'll return null. Otherwise, we'll need to get last error, which is right here. And which DLL is this? This is a kernel 32 DLL. So with that out of the way, we're going to actually go ahead and get into code how to actually open up a handle. So a lot of this, I'm not going to go over the stuff that we went over last video, such as the imports and what it's used for, getting a handle to the DLL. I'm going to go ahead and just type that out. So we do import ctypes. And we're going to do khandle is equal to ctypes dot windll. Do kernel 32.dll. And we'll go ahead and save this to the desktop, and we'll call this openproc.py. Awesome. So now we go ahead and got our handle. What we need to do is worry about the access. So for example, the process all access. Now the way you would add these together, so if we go back to our security process, so 0x0080, so if we wanted to add that, we would come into here and then do 0x0080 and then throw an or a pipe, and then we would add in the next one and the next one and the next one. Now there is a shortcut for process all access, and I'm going to go ahead and show that to you guys now. So in this case, it's going to be 0x000 f0000. We're going to OR that with 0x001 1 2 3 4 5, and there's one more right after that, and that is 0x FFF. So that'll go ahead and sort us out for the access itself. Now again, that's just shorthand for what we do. You can add them all together, and there might be future videos where we'll go ahead and do that manually. But for now, just look at it from this perspective, copy this down specifically, or you can do it yourself just to play around. So the first thing we want to set up is the desired access. So DW desired access, which again is the first parameter, and we're going to set that to process all access. Again, if we pull open the open process here, we can see that we need a desired access. Now there's a boolean next, so b inherit handle. We're going to set that to false. We don't need to worry about that for now. In future cases, we might need to set that to true, but for now, just leave it false. And then DW process ID. Now to get this, we're going to use Task Manager as our process that we want to poke at, right? So we'll do details. We'll set up, where's Task Manager? So it's 2100 is the PID, so the process ID. So you can't put 2100 here. What we need to do is go to a hex converter. There'll be a link to this one in the video, or in next to the video. Keep in mind you can do this in Python, and when you make other calls, which we'll go and do later, when you start looking up like Windows and trying to get the process ID based on a handle, then you won't have to worry about this. It'll already be converted for you. So if we do 2100 and we do convert, that's 834. So in this case, we're going to do 0x834. And that'll grab our handle to point toward, or the process ID in hex to point towards this process. Now what's left to do is get our response is equal to khandle dot open process, and then we pass it all of the parameters in the order that they are expecting. So with that done, we should be able to, if we want, we can go ahead and print this out. So what this is going to do is this is going to actually print out the process handle to the screen, because the handle is going to be what's returned. So if we go ahead and do Python process handle open proc. Oh, misspelled that. Awesome. Let's fix that. So we can see we got a 0. So this means that there was an error of some kind. So let's go ahead and add in our error handling to see what was going on. So if we do error is equal to khandle dot get last error, and we're going to go ahead again, if it's not null or 0, we're going to go ahead and let the user know. So if error is not equal to 0, we're going to go ahead and print error code and go ahead and format that. And we'll go ahead and quit. So we'll go ahead and run this again. A little bit of troubleshooting on the fly, never hurt anybody. So we can see error code 5. So if we go ahead and go up to our system error codes, we can see we get an access denied. Now why is this the case? This is because Task Manager runs with higher privilege than something like, for example, the task or the Notepad. So what we could do is, let's grab the Notepad binary. So this is 5532. Do 5532 convert. That's 159C. Go ahead and save it. And just to confirm, 159C. Perfect. Go ahead and open that. And we don't get anything this time. So you see the difference is Task Manager runs with a different token space and different process space because it is an administrative object. So to test this, we can go ahead and do print and then response. So we should be able to see the raw value of our handle. And we can see, there we go. That is the raw value of our handle. So that means we've successfully gathered a handle. And what we can do down here is do a little bit of extra user notification. So if the response is less than or equal to 0, then we want to let the user know that the handle was not created. So else print handle was created. Awesome. Let's go ahead and run that. So we can see the handle was created. So if we change this to be, let's say 4, or just forget the C and throw in a 4, or anything else, let's do 4. So which is completely random, just made that up. We're gonna get an error code 5, which means the handle was not created. And again, we get our error code 5 because it was trying to open up a process with 4. So it's definitely important to know the context in which you are trying to actually connect to a process. So if you're running in base user space and you try to connect to a process that is a system process or administrator process, or even sometimes a process that you spawned, is more of an admin tool that might use UAC prompts, for example, because UAC will change the token space. So it'll generate a brand new token based on the admin token and not yours. In this particular case, this user's. So when you're opening a process, always keep in mind what level of access you currently have. So for example, opening a process with all access in most cases requires something called SEDebug to be enabled on your current token. So in this case, it would be the command prompt would need SEDebug set up, and it would need to be passed to the Python process when it goes ahead and compiles on the fly the openproc.py. And just keeping that in the top of your head will help you solve problems later. However, keeping this error code is very important, because error code 5 will immediately tell us we're trying to access something we shouldn't be, or we don't have initial access to it. So keep that in mind. Go ahead and rebuild this from the ground up, change a few things around, point to a different process. And what I want you guys to do is take this actually one more step forward, have Python prompt the user for a process ID. So, in this case, 5100, 2100, just the actual process ID found in Task Manager, right? So this particular process ID. So 5532. Go ahead and build that in, have it ask the user when you run this application, they give them the process ID, and you go ahead and convert it and pass it under here. And then once you guys have that all set up, go ahead and upload it to Git to help push your repo a little bit further in your portfolio. Hey everybody, and welcome to our first project video. Now what we're going to be doing here is I'm going to go over a brief overview of what project I want you guys to build before we go into the next video. So the next video is going to be a walkthrough and how you actually build this project or tool in depth and how it actually works. But what I want to do is give you a quick overview and then have you guys build it yourself and try to run and do some trial and error, and then go ahead and post it to your GitHub. So the kind of application we're looking at is called a process killer. We'll just call it proc killer, right? But we want to do this via system calls or Windows API calls. So the first API call you're going to work with is called find window A. That is going to find an initial handle to the window you're looking for based on a name. So we've used this one before, so feel free to go back to the previous videos to look up find window A. But the title that it's looking for here, for example, would be Task Manager, right? So once we have an initial base handle to the window, we want to get the process ID. So that's what this syscall is, get window thread process ID. And that'll give us our proc ID like we did when we converted it manually for the find window, or for the, the open process. But we're going to let the Windows API handle that for us. Then we're going to use open process to actually open a true handle to the process with a little bit more permissions. And then we're going to go ahead and kill the process with terminate process. Now I want you to do this entirely in Python, and the input of the application is going to be whatever the title of the window is. So in this case, Task Manager could be a good test exercise for you. But after every syscall or every Windows API call, so this one, etc., I want you to include error handling. So for example, on the first one, when you do a find window, you want to know whether or not it got a handle to the process based on the window name, or it did not. And if it failed, print out the current get last error, and then let the user know that it failed, and go ahead and exit the application with exit 1. And if it did not, or if it actually did grab the handle, go ahead and print that the handle was grabbed for, this title. And here was the process name, right, or the window name. So that's an example. And then I want you to do error handling for every single one. And then once that's done, go ahead and put it up to the Git account you created in previous videos, because we want to start working on that portfolio. Everything you've done in this course, I want you to push up to the GitHub. So that way you have a start of a portfolio growing, and you'll see it growing over time as you learn more and more. So go ahead and take a stab at this, and once you're done, go ahead and go to the next video, and you'll see a full walkthrough of how we created it. Hey everybody, and I hope you guys all took a chance to actually go ahead and build out this tool for yourself, the Proc Killer. Now, if you haven't already done that, rewatch the previous video and go ahead and give it a try before you start watching this one. Now, assuming you've already done it, congratulations. Now we're going to go through how to build the tool step by step and see if we can learn a little bit more about it. And I'm sure you guys ran into your own quirks and bugs that you had to fix, which is all part of the learning process, and that's why I split these videos up like that. So that way you guys learn as much as possible, because working with the Windows APIs can sometimes be difficult, but at the same time, if you have the right information, you can look up that information, and you have the right error, you can kind of get an idea of what's going on. So the first thing we're going to do is import C types, just like normal. So I'm not going to go ahead and explain that. Now we need a handle to kernel32 and user32, so I'll go ahead and write that. Kernel32, and then we have uhandle for user32. Perfect. Because we'll need user32 for some of the API calls and kernel for some of them as well as to check the error codes. So the first thing we're going to do is we need to dump in those access rights. So we've already done that. I'm not going to go over that. You feel free to go back a few videos, but that's just full access or process all access permissions when we go ahead and use the open process call. Now the first thing we're going to want to do is use our find window A call. But before that, we need to get the user input, right? So LP window name. LP window name is the first parameter that needs to be, or the second parameter that needs to be set in find window. So if we go ahead and take a look at find window, so we can see find window A takes in a LPC string for class name and LPC string for window name. Now we can see here this is just the Windows title, as we talked about here, the task manager, and it's A, not W. So A is for ANSI. So we need to keep that in mind. But what's interesting here is the LP, which means they want a pointer. So we need to keep track of the title itself. So let's go ahead and go back here. So LP window name. So for this one, we're going to want to get the C types .c char p. So what this is, C char p is a char or character pointer in C types. So this will give us a pointer to the information we're looking for, because right here LP is for the pointer. So we'll go ahead and give it that. So this is what we're going to want to give the user input. So we're going to want to get the input from the user, and we want to ask them for enter window name to kill. Awesome. Now, because this is ANSI, not ASCII, which is what this would be originally, we need to encode it. So when we go ahead and encode it, we're going to use UTF-8 for the ANSI encoding. And that'll go ahead and get us our base information. So if we go ahead and print this out, LP window name. Let's go ahead and run it. Oh, misspelling here. Go ahead and save that. This happens. Perfect. So we'll do task manager, and we got our pointer, and that is the pointer address. Perfect. So we're getting exactly what we expect. So the next thing is we want to be able to grab the find window handle that gets returned. So hwind is equal to uhandle dot find window A, and we're going to pass none for the first one because remember, we don't want to use the class name here, so we want to pass it null, so essentially none. And then we want to pass it the LP window name. So that'll go ahead and have us find the window itself. And again, we want to check for the error message. So if hwind is equal to 0, then we'll go ahead and print out that there was an error code. Go ahead and print out an error code. Then we'll also put could not grab handle. Format. It'd be k handle dot get last error. Perfect. And we'll go ahead and exit here as well. So if that's not the case, we know we got the handle correctly. Got handle. Awesome. So again, we're looking for the handle return being 0. So you can see here, if the function fails, the return is null. So it'll essentially be 0 as far as Python when it comes to interpreting it. And if the handle if it succeeds, it'll have a handle which will be a positive number. So if we go ahead and run this, we got our handle. Awesome. So now that we've got our initial handle, the next thing we need to do is grab the process ID of the process that we wanted to look at. So in this case, Task Manager. So to do that, we need to use get window thread process ID, which takes in the initial handle, so the handle that we have here, and it takes in a process ID reference. So the way this works is if we go up to here, get window thread process ID, we can see that here it's a pointer to a variable that receives the process identifier. So this process is one of those where we're passing a reference to it, so the function get window thread process ID can update whatever is in here with the correct process ID as long as the handle is correct. So keep in mind that some Windows API calls will take in something by reference to use it, but as well to update it. So you'll find this is pretty common with Windows structures. You'll create the whole structure and then pass it as a reference, as a parameter, and then the API call will go ahead and update that structure with the information you're requesting. So in this case, we need to pass it a LP dword, which if we go ahead and take our types over here, our dword is ctypes ulong, so we can go ahead and use that. So the first thing we want to do is actually set up our process ID. So this guy right here, we want to set up this initial variable, right? So we're going to do LP DW process ID. Now keep in mind, I'm naming these the same as the Windows API parameters. You can name these whatever you want. Equals ctypes dot c underscore ulong. So that I go ahead and create a base ctypes with ulong, which is an equivalent to our dword as we just saw in the wintypes.py file. Then we get our response, and then we actually issue the API call. So in this case, it is the user handle. So uhandle.get window thread process ID, and then we're going to go ahead and pass in the handle that we want. Now, because this is a reference, remember, it's a pointer, and it also says specifically a pointer to a variable that receives the process identifier. So we have to pass it by reference. Now you do this as long as it's a C type, in this case ctypes.culong. As long as that's the case, we can use ctypes built-in function to actually pass the reference of it over. So if we do ctypes.byRef, and then we pass it whatever we want. So in this case, we'll do this guy right here, and we'll go ahead and pass it over. Now remember, the response here, we're just catching this to check for the errors. So if we go back up to here and we see the return is the type dword, which is the identifier that's created. However, when something fails, it'll be set to 0. If not, it'll have some sort of value. So what we're going to want to do is we're going to check for the response. So if response is equal to 0. Then we're going to go ahead and print out, we'll go ahead and copy and paste this just so we don't have to rewrite the whole thing. Error code could not grab PID, and we'll go ahead and print that out. And we'll go ahead and exit 1 if that was the case. Otherwise, we did indeed grab the PID, got the PID. So let's go ahead and give this a test run on Task Manager. So you see we got our handle and we got our PID. So if we run this again and do task something that doesn't exist, right? So we can see error code 6 could not grab handle. So error code 6, if we look that up, is invalid handle, which is in our documentation over here. So we see here invalid handle, which means when we went to go grab it, it could not find the process, and we errored out right here because we could not grab the initial handle for it. But if we ran Task Manager, it shows up correctly. So right now we've got error handling for our find window A, and we're getting our thread process ID. So we've got all this preset up, and we've got a valid process ID that we can use to then open the process with. So as we've seen before, this part is open process, so this shouldn't be too unfamiliar for you guys. So DW desired access, which is going to equal to process all access, which is why we set that up initially. And then B inherit handle, we're going to set that to false because we don't need that right now. And again, I'm not going to go over this particular API call because we've done this in previous videos. So DW process ID is equal to LPDW process ID. So we're just setting the process ID to the one that we set up here, because since we passed by reference, this API call went ahead and updated that with the correct process ID. So we'll just go ahead and set that. And that's not necessary. We could just pass it directly. I'm doing this so we keep the parameters the same. So the next thing we want to do is we want to get our return of open process. Now open process returns a handle, as we remember. So we're going to do h process. Now this will make the naming of this will make sense because when we do terminate process, the first parameter is called h process. So I'm just naming it conventionally, and that is equal to k handle dot open process. Oh, too many O's. Open process, and then we pass it in all the information we need. DW desired access, followed by B inherit handle, and then DW process ID. So again, that'll go ahead and open up our process. And then if we do if h process is less than or equal to 0, we'll go ahead and print out that there was an error. And again, we'll just copy and paste this for simplicity's sake. Could not grab privileged handle. And we'll go ahead and get our last error. And if that was not the case, we will go ahead and say that we got our handle. Awesome. So now that we've got our handle, we can go ahead and run a test on this. So you can see here we got our initial handle because we found it. We got our PID, and then we got error code 5. So what is error code 5? Error code 5 is access denied. Now, why did we get access denied here when we tried to grab the handle with open process, but not when we did our initial find window, which grabbed a handle as well? So there's a different type of handle. So when you grab an initial handle like what we're doing in find window up here, we're not actually grabbing a privileged handle. We're just grabbing a reference to the object, and that's it. We don't have any special access. There's nothing else needed. It's just a handle to the process to know that it's there to identify it. When we do open process, we're opening a different type of handle that actually has privileges over the process, so we can change things around use that same initial access to grab the token and multiple other things. So this failed because we don't have enough privileges on this command line to be able to do so. So for now, we'll go ahead and right click the command prompt and we'll do run as administrator. Go ahead and click yes. And we'll go ahead and navigate to where I have everything set. So in my case, it's the desktop. And then we'll do Python proc_killer.py. We'll go ahead and run it again. So as you can see, we got our handle. We did not get an error anymore. So I'm going to go ahead and close this one down. So now we're on the administrative one, the one that has a little bit more access, but we're able to get our handle now. And that's because this initial token on this administrator command line has more privileges enabled that allows it to open up a handle to a different process with process all access. So with that out of the way, the only thing left to do is to actually terminate the process at this point. So we'll go ahead and give ourselves a little bit more room here. Awesome. So what we need to do is take a look at terminate process. So we'll go ahead and go up here and we'll do terminate process. We'll go ahead and see what it requires. So it's the first one right there. So it takes in a handle process. So this is a handle, the process that we have terminate access rights to, which is why we had all access. And then the exit code, which is just the standard exit code. If it's similar to us, that same call is used when we use exit 1 as an example. So we're using 1 as our exit code. 0 means nothing went wrong in most cases, and then 1 means that there was some sort of error, and that's how the operating system and most users that run applications are able to determine whether something failed incorrectly or worked correctly. So the first thing we're going to do is u exit code is equal to 0x1. So that's our 1. We could just say 0x0, but in this case we'll do 1. Now we're going to want to grab the response of this one and do khandle, since this is under the kernel, terminate process. And what we're going to do is we're going to pass this h process, which is our first handle, our initial privileged handle, and then we're going to do u exit code. That's it. And then again, we can just go ahead and do some checking here. If response is equal to 0, we'll go ahead and print this one out. There we go. Could not terminate process. Perfect. Else print process went bye-bye. So do an initial quick look over this. So we gone ahead and set up our handles. We set up our all process access so we can quickly reference it. We grabbed the window name as a pointer and we encoded the actual string as UTF-8 for the ANSI. We'll go ahead and call the find window and we check to see if we could grab an initial handle to it. So did it exist or not? Then we set up our initial process ID object that we're going to be passing as a reference to our get window thread process ID. We pass in our handle, and then we do a pass by ref, which is a very important concept that you're going to be using a lot in future videos. So we're passing this type as a reference, so the actual memory location to this API call. And then we're going to check for the error, check to see if we got our PID or our process ID. Then we're setting up our desired access, our inherent handle, and we reset our process ID for our open process so we can open our handle, a new handle with actual privileges this time. In this specific case, process all access allows us to handle the terminate process privilege. Then we go ahead and check to make sure we got that, and then if we do, we go ahead and terminate the process. So let's go ahead and run this. So you can see Task Manager down here at the bottom. So if we go ahead and rerun this, and we do Task Manager, and we go ahead and hit enter, you should see it vanish. Poof, there we go. And we got no errors, process went bye-bye. So this is how you kill a process while using a bunch of different Windows API calls. Now, the code may look a little bit daunting at first, but when you break it down step by step, feel free to rewind the video to take a look at each individual section again. But it's important to understand why we're using this particular type, because it's a D word, and based on the win types in the C types section over here in the CTHOM, which is our C types, we can see that D word is a C types U long. So it's important to keep that as a reference. Just you'll get more familiar with what variable types and C types match the Windows API documentation. So a little bit of it's trial and error. Sometimes it's not 100% matched. You just have to get really kind of close, and then you can ballpark it with error messages from there. And then we pass by reference. We're passing the memory location of this C types long. So go ahead and rebuild this, or if you ran into any errors, this should help you sort it out. If you run into any more errors past this point, even copying and pasting this code, I do have a complete version of it linked to the video. And if you have any additional questions, feel free to open up in the Q&A or message me directly. But I want you guys to fix your other tool if you have any errors and go ahead and upload it to the GitHub.